Homework 4.3, Properties of Logarithms, video 5. Homework due Friday, May 29th at 11:59 p.m. The following video is associated with questions 10 through 13 in the homework assignment. In the first 4 videos, we discussed the product rule, the quotient rule, and the power rule. And in the middle, there was a video proving the product rule, but that video was optional. I've summarized the product, quotient, and power rules here. Just a quick verbal summary. The product rule says the log of a product equals the sum of logs. The quotient rule says the log of a quotient equals the difference of logs. And the power rule says the log of an argument with a power equals the power times the log of the argument without the power. So in this video and the next one, we will be putting them all together to achieve one of 2 goals. One of the goals, which I've already alluded to in previous videos, is expanding logarithms, or more specifically, expanding logarithmic expressions. And the objective of expanding is to minimize the arguments. In other words, to make the arguments contain as little as possible. Now, full disclosure, the benefit of expanding logarithms lies mostly in calculus. I'll explain why after we expand the first one. So what that means is when we get to the next homework, we won't be expanding logarithms as much as condensing them. But again, the objective of expanding logarithms is to minimize the arguments, and which really pays dividends in calculus. I'll go ahead and say it now, because in calculus, it's easier to do calculus to logarithms if their arguments are smaller. So how do we expand a logarithm? Well, in general, that means you're starting with one logarithm and you're going to apply one or more of these rules. For example, consider the natural log of x to the second power times y to the third power. To decide which rules to use, ask yourself what the argument is made of. This argument has a product, and it also has 2 powers. So a not so subtle suggestion that we will use the product and the power rules. But which do we use first? Would you say that this argument is primarily a product or primarily a power? I would say it's primarily a product. You have to use the product rule first on this one. Why? Because you can't use the power rule first on this one. Why not? Because the power rule says what to do when you have a power on the entire argument. Who has the second power over here? Just the x. Now, if it were just x squared in there, yes, we could use the power rule and it would be over that quick. But the power here does not belong to the entire argument, neither the 2 nor the 3, and therefore the power rule does not apply yet. However, this is a product, something times something, and hence we can use the product rule. So if we use the product rule first, the product rule says that the log of a product equals the sum of the logs of the factors. So the first factor is x squared, the second factor is y to the third, and so the natural log of x squared times y to the third equals the natural log of x squared plus the natural log of y to the third. Are we done? I don't know. Can we make the arguments smaller? Is there a rule we can apply now? Yes. Now we can use the power rule on each individual logarithm. On the first logarithm, there's a power of 2 and it belongs to the entire argument. So we can and should use the power rule on the first logarithm. Put the power in front and remove it from the argument. 2 times the natural log of x. Plus, same thing here. This logarithm's argument has a power. The power rule says we can put the power in front and write 3 times the natural log of y. At that point, the arguments are as small as they're going to get. There's only an x left here and only a y. Mission accomplished. We've expanded this expression completely. This reminds me, there was one thing that I neglected to mention at the end of the power rule video, the previous video. It's the same thing I mentioned at the end of the product rule and quotient rule videos. This is true as long as all the arguments are positive. And the reason I'm mentioning that, if this x were negative, that would be bad. But when it's squared, it would become positive, and that would be good. So these would not be equal if the x were negative, because this logarithm would not be defined, whereas the other one would. But again, we are going to assume in all of these problems that everything falls in the correct domains, and we don't end up having logs of negative numbers or logs of zeros. What about the second one? Expand log base 2 of the square root of x over 8y. Should we use the product rule, the quotient rule, or the power rule? Well, does it contain a product? It does. 8 times y is a product. Does it contain a quotient? It does. The fraction. Does it contain a power? It does. The square root is a power in disguise. So, we're going to have to use all three rules, and we have to decide the correct order in which to do them. Would you say that this argument is primarily a multiplication problem, a division problem, or a power? I would say it's primarily a division problem. This divided by that. Now, half of the division problem includes a product, and the other half includes a power. But this is a division problem, aka a quotient. And as a consequence, we should use the quotient rule first. The quotient rule says if you have a log of a fraction, you can split it into the log of the top, so log base 2 of the square root of x, minus the log of the bottom, so minus log base 2 of 8y. But is that all we should do? Have we reached our objective? Have we minimized the arguments? No. I still have more rules that will allow me to expand further and make the arguments even more minimal. We'll deal with the square root in a minute because I want to focus on the product rule next. Because there's a very stealthy trap here. The product rule is going to be applied to this logarithm because it's the log of a product. And the product rule says the log of a product equals the sum of the logs of the factors. So the 8 gets its own log and the y gets its own log. Log base 2 of 8y equals log base 2 of 8 plus log base 2 of y. And we still have the first log over here, log base 2 of the square root of x. But here's the trap. One was between these two logarithms before I used the product rule. A subtraction. Guess what needs to go here? A subtraction. But guess why what I have written is wrong? Think about it. This subtraction, or negative if you will, belonged to log base 2 of 8y. That just got expanded into two separate logarithms. So if the minus belonged to the original, then it has to belong to both of these. In other words, that minus applies to everything that was a consequence of using the product rule. There has to be parentheses around the sum. Oh no, we have a minus in front of parentheses. We've heard this story ad nauseum. If there's ever a minus in front of a parentheses and the parentheses contains multiple terms, this one has 2 terms, they're separated by the plus, then the negative gets distributed to all of it. So we still have the log base 2 of the square root of x, but now we have minus log base 2 of 8 and minus log base 2 of y. That's the trap. I know the product rule sticks a plus in between it, but that product was in the bottom of a fraction, which according to the quotient rule stuck a minus in front of the whole thing. Here's an easy rule of thumb. Denominator factors get negative logs. Let me say it again. Factors from the denominator, when you're expanding, get negative logs for this reason. Now, are we done? Nope. I can still minimize the arguments. On the first one, I have log base 2 to the square root of x. But in a previous video, we talked about how radicals can be written as powers. Do you know what power is the same as the square root? Well, what power is currently on the x? 1, that's the numerator. For a square root, what's the implied index? 2. It would be convenient, especially if you're going towards calculus, to just automatically go square root of x. Oh, you mean x to the 1/2 power, because it's that common. So if we use the power rule, without me manually rewriting the square root of x as x to the 1/2 inside the logarithm, because I could, that 1/2 would come down in front, and the first log would become 1/2 log base 2 of just x. That argument has been completely minimized. There's nothing else I can remove from it. Now, before I write the last two, some of you might be going, I know the answer to this, I know the answer to this. Good. Any numerical logarithm, you should ask yourself, can I answer it without a calculator? Log base 2 of 8 is asking the question, what power turns 2 into 8? Well, what power turns 2 into 8? Third power. So instead of minus log base 2 of 8, I should just write minus 3. And then minus log base 2 of y. So not only have I minimized the arguments, I minimized the number of arguments I had in the first place, because the middle logarithm actually got evaluated. No more logarithm, no more argument. So if my goal was to minimize the arguments, mission accomplished. It's really not that difficult to expand logarithms. In a nutshell, if you take the log of a multiplication and or division problem, factors on the top of the fraction get positive logs. That x got a positive log. Factors on the bottom of the fraction get negative logs. And of course, power rules apply, and if you can evaluate a logarithm, that applies as well. I did mention that this applies to homework questions 10 through 13.